So let's get started with our next major set of topics. This is going to feel very different. Let's start. Let's define something called a sequence. Okay, a sequence. Something's wrong here. There we go. A sequence is a list of numbers and written in a particular order, explicit order. Now, because the sequences are typically infinite, we would like some sort of shorthand for talking about all those different numbers. So we typically talk about these sequences using the brace notation and referring to what's that?
No, I can't, like when I draw it, it always looks awkward.
Ready?
Is there a secret way to do that?
Yes. A brace is a forehead, a nose, and a chin.
I've never looked at that. Yeah, it works. That actually
A forehead, a nose, and a chin.
I'm never going to look at that same.
kind of reminds me of a tuna fish at my buffet.
Trevor, would you write that down into your list of quotes for the year? Yeah. All right.
And that's on the recording.
Yeah, it is. All right. So inside the braces, we put what's referred to as the nth term. But we believe that these sequences begin with a first term, a second term, third term, and we have some sort of mechanism for finding out what the nth term is. We have two different mechanisms I'm going to show. One of them is called the explicit, the other one's called the recursive. Once you get these notes written down, I will go to the next slide. Oh, Brian. She said, she told me she was going to be here. All right. May I go to the next slide? All right. So, let's take a look at this particular sequence. Again, I can define the sequence by defining the nth term, and I use this notation. A sub n is equal to, and in this case, A sub n is equal to negative 1 to the nth over n squared plus 1. So let's go ahead and let's see if we can kick out the first 6 terms in that sequence. Well, the first term is going to be when n is equal to 1. So when n is equal to 1, I've got a negative 1 to the first power, like a negative 1 on top. And I've got, what on the bottom? 2. 1 squared is 1 plus 1. Okay. So there's our first term in the sequence. How about the next one? One on the top, because negative 1 to an even power is positive 1. And then what is it? We're on 2. 2 squared, yeah, 5. Yep, good. Okay, negative 1, and so at some point we say, oh, I know how that negative thing's going to work, right? It's just going to alternate back and forth between negative 1 and positive 1. And this next one is 10. Oops, comma. Positive 1, 17, I wrote 16, because I'm thinking about the squared. Negative 1 over 26, positive 37, and then we say dot, dot, dot. But what about the nth term? Well, that is the nth term. What about the 100th term? The 100th term, 1 over 2, 3, 4. I think I got 100,001. Is that right? No. It's 10,000 plus 1. Hal, did you have enough time?
Yeah,
Okay.
yours for
No problem. All right, 10,001. There we go. Great. Easy, right? I do say so. Let's see what else we got going on in this. Everyone okay with that? Because I think that stuff's going to disappear. Nope. Nope. Okay. So here we go for another problem. Now, the first problem we did was called an explicit Did you need more of that?
Oh,
You looked panicked, Emily.
I was still trying to write from the first slide, so I missed all that.
All right? We're okay? I'm waiting for your permission because I won't go on until I get it. All right. Okay. So here we go. Here's another way of defining a sequence. This is called a recursive definition. In a recursive definition, we define one number in the sequence based on a previous number in the sequence. So why don't we take a look and see if we can get the first 4 terms going on here. Well, explicitly, the first term is going to be 4. Now what about the second term? Well, this expression says if I want to find the nth term, look at the n minus 1 term and add 2 to it. Indeed, it is 6. If I want to find b sub 2, take b sub 1, the previous term, and add 2 to it. How about b sub 3? 8. The rule is take the previous term and add 2 to it. Excellent. How about b sub 4? Take the previous term, add 2 to it, get 10. Great. Now the harder thing. What about b sub n? How are we going to describe the nth term? Oh, I'm sorry. They don't want the nth term. They want the 8th term. 8th term. Can we, by looking at this expression, looking at the terms that have come before, can we come up with some general way of getting at the 8th term without calculating the 5th, the 6th, the 7th terms? What's that? So you want to call b sub n is an one more time? N times 2. N 2n plus 2. Now does this rule work for all the previous cases? When n was 1, we got 4. When n was 2, we got 6. Okay. And now that you've seen the trend, you see this common increase. We're going to be able to say that the 8th term is going to be 18. Is that good?
Yes.
Okay. Great. So far, so good. Does this feel good? Doesn't feel like calculus, does it? That's why it feels so good. It's coming. All right. The sequence that we just looked at has a special name. It's called an arithmetic sequence. An arithmetic sequence is any sequence that can be written in the form a, then a plus d, then a plus 2d, plus a plus 3d, so on and so forth, for some constant d. The d is referred to as the common difference. And every arithmetic sequence can be defined using that recursive definition. That a sub n is equal to a sub n minus 1 plus that common difference. So it looks like a sub n has two definitions here. It is that, and it's the explicit definition that a sub n is a sub 1 plus n minus 1 d. Does that work for the previous example? Let's see. A sub 1 was 4 plus n minus 1 times the common difference in that case was 2, or 4 plus 2n minus 2, which was indeed 2n plus 2, just like Jordan came up with. Okay, so an arithmetic sequence defined by always adding the same amount to the previous term, that also can be then rewritten in this explicit form. So far, so good? Wonderful. Any questions? No. All right. Let's continue on then. How about this arithmetic sequence? -5, -2, 1, 4, 7. Can you tell me what the common difference is? D is what? 3. Can you give me what the 9th term is going to be? Well, what did we just find out? That the explicit definition of the nth term is going to be a sub 1, what was the rule again? Plus n minus 1d. And then you say something. Like this a sub 1 in this example is -5. D was 3, -5 plus 3n minus 3, or 3n minus 8. So, to answer the second question, what is a sub 9? 3 times 9 minus 8. My brain's not working very well today. 19. 19 sounds good. Oh, I guess I didn't do it the way they wanted us to do it. We found the explicit rule and used it to find the 9th term. And then in part D, they asked us what's the explicit rule. Bah. Okay, let's just get the recursive rule out of the way. What's the recursive rule for this particular problem? A sub n is equal to 3. Okay. All right. Not so bad. Still doesn't feel like calculus, does it? Not yet. All right. Your turn. Working with partners. Your turn. You know what? Either Nicole goes back or Marissa comes forward. Which way you want to do it? Okay. Danny, why don't you join the Mateus and Aaron group? Yeah, I'm going to stand over here.
Might be his. Nope, might be his.
that D
Look like this.
So these are separated by.
well,
Okay, so
so natural log of 3 is natural log of 2
And then like, oh,
times natural log of 3 equals natural log of 6.
the difference between those.
So.
So yes.
I never ever read this section. These were the sections that like we didn't really get into.
Well, like this one's like different because it's like, you know, natural logging, you're subtracting, you're actually dividing. Okay, yeah, so like, I can't see like both ends. No, it's just natural log subtract.
Okay, so yes, so what I did is the first two things,
We need to figure out what this
the natural log of 2 use this equation.
No, what that number is in a more condensed form.
Found out that D natural log. So if you plug that in, you get to here. And then we have put it up, just like you bring it down. Like that's just like this example, when you bring the 8, you can bring it down to 8 times 3. Or but you can also bring it back up. So each 8 you can bring it back up, and then if you have 2 natural logs, you can multiply them together. So that's simply both of them, like so you can have it. So that's and then so it's the natural log of that. So yeah.
Is there anything over here that,
It could possibly be on.
it could be on the floor? Why would it be on the floor? What are you missing on, Rico?
Oh, yeah, it's right here.
Oh, Edmund.
I did not put it on the floor.
Right, Rico. Okay. So help me out, because I'm a little slow today. I've seen the pictures of the devastation in Japan, and I'm all out of sorts. So
Wait, what?
Oh my gosh, what did anything happen when it hit like Hawaii?
nothing compared to what happened in Japan.
What just happened?
They had an earthquake last night. Nearly 9 point.
Hi.
And then the earthquake itself caused a tsunami. So not only did they have this terrible destruction because of the earthquake, but then these floods came through. I mean, it's so. I'm going to write D must be the natural log of 6 minus the natural log of 2. Because in order to find the difference, I'll take the later term and subtract it by the earlier term. Any help here? This is equal to the natural log of 3. Because this is equal to the natural log of 6 divided by 2. Remember those log rules. They'll be helpful. All right, so we found out what D is. What is the 9th term? Well, should we skip to the explicit rule, or should we just say, you know what, first, second, third, fourth. We see that these numbers are always going up by 3. But yeah, let's go ahead. Let's go down to part D and see if we can define the explicit rule. Explicit rule again is first term, natural log of 2 plus n minus 1 times D, the common difference, or natural log of 2 plus natural log of 3 times n minus the natural log of 3.
So ln of 2/3 plus ln 3n.
So the natural log of 2/3 is an excellent way to put that, plus the natural log of 3 times n. I guess we could use it to find out what is the ninth term?
9.48.
Oh, how not elegant.
You asked the question, I answered it.
You gave an answer. I gave an observation. Alright, so if we did that, what do we end up seeing? Can we actually get that into its nice form like this? I would suspect that I could rewrite this as natural log of 2 minus the natural log of 3 plus natural log of
It's not pretty.
Doesn't natural
Wait, in
log
the
of
book
2/3
they-
plus natural log of 3 simplify to natural log of 2?
That's what I was thinking.
Oh no, but it's a 9.
I don't know. I mean, what I'm looking at is that this is 8 natural log of 3 plus natural log of 2, which is natural log of 3 to the 8th power, which I don't know off the top of my head.
6,561.
Edmund does.
No.
Times,
Times
I thought it's
Times 2, not, yeah, you're right, it's times 2. Times 2. So what did you have, 6,000?
561.
So it'd be, this would be
13,122.
22? Alright. Well, yikes. That was harder than I would like it to be. Let's do an easy problem. What's the recursive rule in this case?
That's what you're doing?
Yeah. It's the recursive for these arithmetic sequences are always in the form a sub n is equal to a sub n minus 1 plus d, the difference. Every time.
Wait, you said minus the difference?
Plus the difference.
Plus the difference?
Every term got bigger by the difference. Alright. How many people would like to leave natural logs behind? Okay, let's wave them by. Alright, let's do something different. Let's define a new kind of sequence. The geometric sequence. So the geometric sequence is a sequence that's in the form A, AR, AR squared, AR cubed, so on and so forth, where R is called the common ratio. So D for difference, R for ratio. A for apple, J for jacks. Sorry. Now, the nth term can be described explicitly as we stated here as A times R to the n minus 1. That's one way of defining explicitly what the nth term is. But of course, it wouldn't be fun if we couldn't also describe it recursively. And the recursive definition is going to be, if you want to find the next term in the sequence, take the previous term and multiply it by R, the common ratio. The geometric sequence. Are we ready to apply the geometric sequence to some seemingly random set of questions? Alright. People are still writing notes, so I'm going to go back to you. Oh, I haven't been paying attention to you all year, Trevor. Indeed. since Charlie's not here, and maybe for, when he found out by reading the sixth book that Dumbledore died, hadn't he been looking at your shirt at all?
Did you just find out a couple days ago?
Yeah, Aaron, was it last week that he finally got up to book 6? And,
He knew it happened.
He must be really sheltered if he didn't know that.
Yeah, he knew it happened.
well, I mean, but he seemed really distraught.
Yeah. I mean,
Maybe he read it and he relived it.
Maybe he's just shocked.
he saw the movie,
Maybe
but
he is very honored.
then
He kills Dumbledore.
Okay.
Spoiler
Oh, it's spoiler for all those people who watch this in the future. Sorry.
Spoiler alert. Dobby dies.
Oh. That's, okay. I'm sorry. You got it there?
Yeah.
Okay. So let's apply the geometric sequence of what we know about the geometric sequence to the sequence 1, -2, 4, -8, 16, etc. What's the common ratio? -2, says the back row. Let's see. If I take 1 and multiply it by -2, I get -2. That gets me to the next spot. If I take 2 and if I take -2 and multiply it by the common ratio, I get 4. Sounds good. Okay. How about the 10th term in this sequence? Well, you know what I'm going to do? I'm going to go cheat, and I'm going to go to the explicit rule. What's the explicit rule for this sequence? A sub n is equal to the first term, 1, multiplied by the common ratio, -2, to the n minus 1 power. So if I want to find the 10th term in this sequence, if I want to find a sub n, I'm going to go ahead and say 1 times -2 to the 10 minus 1 power. And of course everyone knows that that's -512. Actually, I never memorized that. What I memorized is 2 to the 10th. It's 1024. So it must be half of it.
Have you ever seen SNL?
Saturday Night Live? Yeah, I used to watch it when it was good.
Do you know Penelope?
yeah.
No.
I've been doing that to a long time. It's like, well, I memorized this. It's like, well, actually, I memorized it before you did. So.
It sounds like a similar character that was in a previous edition of Saturday Night Live, where John Lawrence, he had a recurring character which you would just lie.
Oh no, this character, anything you do,
She's a topper.
like,
She's a topper.
One of them.
like this. There's this one episode. Some lady's like crying. She's like, yeah, actually, my cat just died too, and I'm closer to my cat than you were. I've had my cat since I was 4 years old. Because she's like, I've had my cat since I was 5. She's like, I've had my cat since I was 4. So I'm just a little bit more attached than you are.
Well, the line character is similar to that in that it's like, yeah, I can fly a plane, I can fly a near jet, yeah, I can fly to the moon, yeah, me and my girlfriend, Morgan Fairchild.
Sounds like he's using a cow now.
All right, continue on. What's the recursive rule for the nth term? A sub n is equal to n minus 1 times -2. So we got the explicit rule, we have the recursive rule, we can find any number in the sequence.
Oh, so, you can start doing these verses now.
That's a very good question. The answer to the question is that I am building up this idea of using a recursive rule because I'm going to need it in that next chapter. When we do something called infinite series.
Why is the next chapter?
because time goes forward as I move to the right. This is my world, not yours. All right. All right, your turn. And,
All the writing's gone. Oh, wait, no, there.
no, it's not.
Why is it negative?
Why is it negative? So we think about,
Oh, it's to the ninth term. Never mind.
yeah, well, no, the 10th term is going to be negative 2 to the 9th. It's going to be an odd number. Are you ready now? Are you sure?
Yeah.
Okay, here we go. Your turn. Billy Crystal also had a very funny character on Saturday Night Live. He and Christopher Guest had this running gag. Because they would just do genuinely talking things.
I was like,
Yeah, this is fun. Your ears, see how far you go. And then when you take one of those, you guys
did you get it?
Oh, I did.
just kind of gap it.
Most of these you can just use.
Oh, that's
The one with
Your
jam.
first term, which is 10 to the negative 2.
Especially this thing, it's like
You had to, cat and garlic. Garlic cat.
I like old school smell better than you talking about
See, I'm old enough to remember the original cast, so. You know anyone who's on the original
no,
cast?
it's talking about longer than you've been alive.
Which I need a couple.
with the Adam Sandler.
No, I've never seen an Adam Sandler movie.
Why not?
Which one?
Just never got around to it, I guess.
Make it sound like something really don't like.
Oh, wait, this is off and on.
Oh, Big Daddy the movie?
Yeah.
Okay, yeah.
It's like, why do you give us? You do all the easy ones and you give us all the hard ones.
What's the R in this case? Come on.
R is
10. Because if I multiply 10 to the negative 2 by 10, I go to 10 to the... It's probably easier to see here and here.
Yeah, that's
Yeah. It's probably easier to see in the later one. So R is 10. So the explicit formula for this is going to be 10 to the negative 2 times 10 to the n minus 1. And given that, we should be able to find what about the 9th term? 10th term. So what's the 10th term? The 10th term going to be? Let's see. 10 negative 2.
Couldn't you just take, couldn't you change that to that end then?
Yes, you could. The microphone didn't pick up your brilliance just then. So I'm going to say, so Anthony said, couldn't we just rewrite this as 10 to the n minus 3? Ooh. Indeed. Okay, which makes this problem a silly way. It's a silly way to do that then. So the 10th term is going to be 10 to the 10 minus 3, or 10 to the 7th, or what was that? 10 million. No, sorry, you even said that my pinky goes up.
Really?
All right. So we've got our R, we've got our 10th term, we've got our explicit. The only thing that's left is recursive. A to the nth term is going to equal times 10. All right. What could possibly be next? A graph. Actually, not a graph yet. We're supposed to be moving towards graphs, but we haven't got there yet.
Hey, I didn't get this.
Okay. Hey, I'm telling you that 6 and 48 are the fifth, the second and fifth terms in our geometric series. Can you use your mad math skills to find out what the first term, the common ratio, and the explicit rule is for that sequence? It's like partial knowledge. I give you this much, can you find out everything else? It's the second and fifth. I can see Jordan, the wheels are already turning in Jordan's head. How is it we're going to get from the second to the fifth term? We're going to multiply something by it 3 times. So can I write this? Can I write 6 times r? Wait, 6 is the second term. 6r is it's the third term. If 6 is the second term, and I multiply it by some unknown ratio, I'm at the third term. Fourth term. Fifth term. And where do I end up when I get to the fifth term? Equals negative 48. I started at the second term, I got to the fifth term. Yeah. Negative 3 says Edmund.
Well, no. R is -2.
R is negative 2.
The first term is negative. The first term is -3.
Okay. How'd you get the negative 2?
Well, what I did was I divided -48 by 6, and since there are 4 terms right there, so there's the second, the third, the fourth, and the fifth. Divide -8 by 4, and r is equal to that. Or you can take the third.
I take the cube root.
Yeah.
All right. So we got R, and go ahead and you've already worked out what the first term must be then?
-3.
-3? Can anyone explain his answer? 6 divided by, to go backwards we divide by. To move forwards we, notice how now forwards is back the way you want it, right?
Oh, that is the second. Oh.
Okay, great. What's left? No, on this problem. What's the explicit rule? A sub n is equal to. In general, it's A sub, not A sub n again. The explicit rule is that it's A sub 1 multiplied by r to the n minus 1. And in this case, that means -3 times. You know what? Maybe I can show some Anthony-like brilliance. You ready? Maybe I could rewrite this. Ready? I'm going to rewrite this as -3 times -2 to the nth divided by -2.
Actually, I already did that before you did.
And so another way of writing this rule could be that it's 3/2 times -2 to the nth. Now the downside of this is you can't easily see what the first term is just by looking at it. But it could be rewritten that way. Sometimes maybe those jerks will give you it to that way and they want you to find out things. Those jerks meaning those people who write the tests. I mean, is this still a geometric sequence?
Yes.
Oh yeah, it is. But it's not in a form that we like. No, we don't like it. But they could ask you questions like, here's a geometric sequence, what's the first term?
Or maybe if you can just figure out the relationship between the R, because we can still identify R, and they give it to you in that form, and the denominator, the fraction attached, or if there's no denominator, then kind of working it like that.
Yeah.
Yeah. N equals 1.
Oh, you
What
could
should
put
I
it
ask you though? I'm so confused on what question to ask you.
You could say rewrite it in roll. Yeah.
And
It
it
could.
would be easy. You could just plug in 1 and then you'd get your A1 and then you would have everything else you need.
I'll put blinders on.
Yep. All right. But maybe that's exactly what I wanted you to think. All right. All right, get your calculators out because now it's time to do the graphing stuff. Parametric. Okay, so here's the idea that while it's great to do all this manipulation using algebra and stuff like that, we also want to think about sequences as being something that we look at graphically. So one of the things though is, can we get our calculator to do the kinds of things that we want to do? And that's a little bit tough. But we can trick our calculator sometimes to do things having to do with sequences. One of them is to go into parametric mode. So let's say I have this. Sequence, -1 to the nth times n minus 1 over n. By the way, that particular sequence is not geometric.
Why are we going? Don't we have like sequence?
We do. I'm going to get to it too.
Oh.
All right. The syntax on the sequence mode is really peculiar though. So I want to handle this easier case using parametric. So this is neither geometric nor arithmetic, by the way. Just throwing that out. All right. So if you want to graph this, one of the things you can do, of course, is if we're going to do this particular one in parametric mode. So let's go ahead and go mode, and then choose parametric mode from that fourth menu. And also, instead of going connected, yep, I want dot. The next thing we do after setting parametric mode and dot mode is that we're going to put into the y equals menu that x is t. Now in this case, my x is going to act like my subscript. And then in the y equal mode, we're going to put the formula for the nth term. And I'm a big fan of the new fraction mode. I mean, I really like the ability to write this t minus 1 over t. How do you do that? Do I have my calculator running? I do. To get into that mode, I might as well just repeat the problem there. Start screen.
See, my calculator, I left it and I put the date for a while. Because I was afraid I wasn't going to like it.
That's me too.
But then
All right.
I got it.
So t, and then it was -1 to the teeth. Okay, how do I do that fraction mode again? It's alpha f1, which you know better as the y equals menu, and that first option n over d, numerator over denominator. Oh, poop. Golly, that was not what I wanted.
I just did the multiplication sign and then did it, and then I did the multiplication sign.
There we go. Multiply by. There's my fraction. And now, what was it? It was t over t minus 1?
What's the second one? What's the U? Like this.
No, other ones are above. T minus one.
It's t minus 1
Over T.
over t. There we go. Anthony, you asked a question about what's that other one?
Yeah.
All right. If you want un over d, if you want a mixed fraction,
You can change something into a mixed fraction.
you can write something as a mixed fraction. You can write 5 3/8.
Is there a way you could get
And then number 3, convert a improper fraction into a mixed fraction.
No, I'm talking about like also if you did that then you could change it into a decimal.
And then fraction to decimal is number 4. Yep. All right. Let me get out of there. How do I get out of there? I want to get rid of that. There we go. So there's setting up the expression. Now what do? After that, we're going to go into our window and we're going to set how t is going to, where's t going to start? Again, t is our subscript. We want it to start at 1, and we want it to get bigger by 1, and that's why t's step is 1.
So T's just n.
T is n, exactly. I want to put a J in there. TJ Maxx.
What's that?
TJ Maxx?
Oh. It's like what's a J max?
What's that? Yeah, there's 2 X's in TJ Maxx. All right. After we set those, also, set X goes from 0 to 20 by 1s, and Y max, let's have that go from, in this particular instance, from -2 to 2 by 1s. And by the way, I think these cascading screenshots are quite sharp. What? I did do that. Yes. All right.
Earlier I was about to ask you, how did you get both screens up there at once, then I realized that you copied it. Like, how did you get the back screen and the first screen to just pop up instead of, like, exiting out of the back screen?
All right. And then lastly, you hit graph, and there's your graph of that geometric sequence. We are pretty far away from being able to make the homework at this point. At least, well, wait, hold on. Wait, there could be someone who says, you know what, I'd rather do a little bit over the weekend, so I'm not so pushed on Friday. Here's what the assignment is going to be. If you want to start looking at it now, that would be great.
Hey, I'm away.
We'll see you on Monday, Charlie.